Joining me this morning is engineer Phil
Engineer.
Beisel. So, Phil, I grew up under the tutelage of an engineer. My dad was an electrical engineer. He was actually spent his entire career trying to encapsulate transformers, the kind you get up
Yeah,
on
those
your pole, the
big circular
electric.
looking things. Yeah.
Right. And he wanted to encapsulate those in epoxy. And then that way you could plant them underground and be no danger of fire from oil when these things explode, as I've actually seen one explode one time when it was hit by lightning. Actually got to witness that. I've been in that environment, been in that engineering environment. Now, the thing about you is you do not have a pipe. No pipe, no engineer. I mean, how can that be? How can you possibly be an engineer? You have to think through your words carefully while you work with your pipe.
I suppose.
So I missed the pipe. I missed the pipe. So this is the world that I grew up in. I really understand engineers. I guess I have a little engineering talent myself. I do have patents. I have invented many engineering elements of the factory that I built. But I'm not an engineer on your level by any stretch of the imagination. But what I want to do this morning is maybe bridge the gulf. You ran a post this morning and you said you think there's a lot of folks out in our community who are not engineers, obviously, and maybe don't even have an engineering bent, and that sometimes might be going, what in the heck is Elon doing? What the heck is Tesla doing, or SpaceX, or any of the companies? Because their focus is the engineering of the product line, engineering of what it is that they're hoping to execute, as opposed to necessarily the marketing, or the product ID, or the company label, et cetera, et cetera. So I've picked five for you this morning
Okay.
that I'm hoping that you will elucidate, explode, um, give us some more understanding about. So how's that sound?
Sounds good.
All right. So number one, talk me through why we have safety riders in Austin and why it's taking so long to get to the next major phases. I mean, it's been 2 months since we started this project. We still only have 15 or 17 cars out there. What are these engineers thinking about
Yeah.
when it comes to to getting into, the real business?
Right. And nothing's happening, right? The
Yeah,
schedule
nothing's
thing.
happening.
Yeah.
Yeah.
Yeah. I'd say Tesla's version of nothing's happening is that engineers in the Tesla AI division are practically working 24/7 and will be this whole entire weekend on that problem. So, yeah, I mean, it's super interesting. I thought that I've always thought that I had this perspective where I could bridge or help bring that perspective to folks that haven't taken up an engineering discipline as their career,
Right.
and and I think that coming from an engineering, so my background is software engineering and then software engineering management, um, and I think that it's a weird world in a sense of how we operate or some companies operate, and and it does need to be decoded and translated. So in the case of what's happening, that ground game is very interesting to me because to me, I would say, if it was my organization and I was running this, it's exactly what I would do. I would say, okay, for the first time, and I wouldn't say that, exclusively, but for the first time, I've been given this license to go out and do um, a really hard beta test in the field,
Mhm.
where I'm putting Robotaxi out there. I've got these safety observers, which are my eyes and ears, in an important way. We should talk about, um, and then I, as an engineering manager, can collect that feedback, and I can triage a set of issues, and I can work those issues into a set of, okay, let's go solve this one, let's go solve that one, let's go solve. And it reminds me of something that people do, like in performance tuning. Let's say they have a database running, and database is slow, and so let's say it's a SQL database and kind of traditional structured database. And a good process is that you would go in and you would look at your top 10 worst performing queries and you would knock them down. And once you knock them down, now you're left with a system that runs really fast, but now there's a new top 10, right? But those top 10 are not as important as the previous top 10. And you do that maybe 10 times, and you've got a really pretty awesome system. And I think in a sense, that's what's happening here. That's exactly what's happening here. You have, they're taking in feedback observationally from their observers. They are looking at the issues. Some are safety critical issues, but I would argue that most of them are not. Mm-hmm. A lot of them relate to just smoothness of drive and drop off and pick up. Where are these pickup locations? Because that's something like, if you think about FSD, FSD was never, FSD was end to end, door to door. But honestly, it really wasn't door to door, right? Here's a situation where a robotaxi has to pick somebody up at a specific location and then drop them off at a safe and sensible location for whatever place at their destination. And it's hard, it's hard to do. So what they do is they collect this feedback and they triage. First step, triage the information, and then second step is like assign a team or a sub team, a tiger team, whatever you want to call it, to go after a problem and really nail it. So imagine that they see one instance in Austin where the vehicle takes a right on red and it's not supposed to, and they then identify, well, what kind of training data have we used in the past on that? Oh, we have in this particular case, we have a kind of a vacuum of training data. So they collect some training data, they fine tune the model, they give it a try, they see how that works. And then other teams or other potentially sub teams here are pulling in and doing their own things. And then eventually they bring that stuff together in a kind of, if you will, a release candidate. And then they go through a set of testing on that release candidate. And then that resulting build, software build, if you will, even if it's a AI model, it's still a software build, gets put into the fleet, right? And then they're able to go on to that next top 10. So that's what's happening. And it takes a while because, frankly, I've seen this so many times in so many different ways. You go in thinking, okay, we know that we're going to see a certain number of issues, and we plan so much time, and we do this and we do that. And then the product touches the customer and all bets are off. Everything kind of changes or gets more material or focused and so now the team looks at a problem and says, we're gonna run that out to the finish line, resolve it, and move on to the next problem. And honestly, how the team, I think, is operating shows the excellence of the team. Because if the team is simply saying, let's move on and let's, how do I want to say this in a presentable way? Let's acquiesce to management's desire to scale fast, right? I mean, here's what we have. We have pressures here. Elon is clearly pressuring the team. Let's go. And the team is pressuring itself. It has a mission, but it's also pressuring itself to try to get to that next phase, what we might call the scale out phase. But at the same time, they're super concerned about the quality, safety aspects of the product. So they're pushing back on management. Now, Elon probably better than most understands the constraints and how they're operating. A lot of management doesn't understand that. And in fact, I would say this, there are some companies where management so so misunderstands the reality of that, that it is only the engineer's opportunity to get the product in the field that they have the opportunity to actually do the thing that they wanted to do, which is test it in the field and get all this feedback.
Right.
I mean, in other words, they're crying and screaming about they want more resources, they want more test engineers, they want more of this, they want more of that. And management in those organizations is saying, no, 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 I thought you did a good job. I thought everything was fine. How could you ask for more resources if you're a quality organization? And, that's just a misunderstanding of the realities of engineering 101. And I think Elon gets that. So Elon has this other part of him, which is, he's sort of in some ways the marketing head of this engineering driven company called Tesla. And so he's got to put on a certain kind of face for it, saying, hey, I see momentum, I see it going forward. And by the way, he's just generally an optimist.
Yes.
I mean, because he would never do the things like Starship 10 launch, and you don't do that if you're not optimistic. You just don't even do it. It wouldn't happen. So, as this kind of inherent optimism in his engineering makeup, he's going to put on a good face, and a lot of people will misinterpret that. They'll say he's lying, or it's just garbage, in my opinion. I think that's just misunderstanding the typical optimistic engineer who believes in a future state as a day away and can compute all the little things along the way, but doesn't really, and I think that's what's happening with the Robotaxi team. It's like they said to them, or the FSD team in general, hey, we're about to do this trial. We're going to collect feedback. We're going to put these safety observers in. What is a safety observer going to do? It's going to be the first eyes and ears, like in a real serious way. Like you have a customer using FSD, and they created an intervention. Why do they create an intervention? Lots of reasons. Some of them are actually silly, like they just want to change directionally where they're going. And then Tesla's got like a fire hose of that stuff coming in, right? So it's really hard. How big of an organization do you set up to triage that fire hose, right? When you get into a situation like Robotaxi, you can clear that clutter. You can get rid of that kind of mess, and you can say, okay, we have 10 vehicles or 12 vehicles or 15 vehicles in Austin. That means we have that many safety observers. We can train those guys to tell us specifically where an issue is occurring. Then we can laser focus, go in, pull the data on that issue, decide if that's a real thing or not. If it's not a real thing, we can retrain the observer to make sure that he doesn't report that kind of false, thing in the future. If it is a real thing, we can get to work on solving that.
So let me stop you. Okay.
Yeah, lots there, right?
Well, yeah. So the thing that's popping out to me right now is I think the average person out there thinks that these safety trainers, safety riders, are just that they are just there to pop the button on the door.
Yeah, no way.
If they need to stop the vehicle or to intervene in an accident or something like that, or something goes wrong with the passenger and they need some kind of help. What I'm hearing from you is this safety rider, which I mentioned, I think the very first time I started talking about safety riders, it occurred to me that they probably after every ride, they're not taking notes. And they don't have a tape recorder that they're speaking into while the ride's going on. But my guess was at that time that after every single ride, when they let the passenger off, that's when they record something. That's when they write it down.
Yeah.
And that by the end of the day, they've got a stack of stuff, and they're now having a conversation with an engineer who is not only hearing the new stack of stuff, but also, as you said, retraining them, not only to not observe or not care about things that they don't need to care about, but also this is what we've observed.
Right.
Here are things we'd like you to observe now. So this person is actually an important link in the discovery phase, as opposed to just being this idle individual who happens to be ready with a switch on the door to stop.
Yeah, no, I mean, there's this person, the observers, these folks are trained to some level before, right as they hit the go switch on this thing. They probably went through a month of kind of training, and They realized this is what we want it to look like. And then after hitting the go switch, they realized, oh, okay, that's not the kind of feedback we want. Or let's, as you said, let's give them an idea what to look for, things that they want. So it's a process. It's a process, and it's a process that where engineering is now directly connected to a human who has eyes and ears to be able to see what the robotaxi is doing. Is it centered in the lane? Is it doing this? Is it jittering? Is it that? Customers are not going to report that information. They're not going to report it in a quality way or a way that's going to be able to easily be absorbed by the engineering organization. Okay.
Yeah. So now where would you see this training person going? Because everybody's like anxious to get that person out of the seat. So the stock
Yeah.
go up.
Well, I mean,
So would you anticipate, would you be, what somebody posted this morning, they think that the safety riders will still be in the seat a year from now.
no.
Other people are projecting that, I said the other day, maybe they aren't even going to have safety riders at all in Chicago, for instance, because they will have done their job in Austin. I mean, I'm not predicting that. I was saying
Yeah. Yeah.
that would be the full range of possibilities, I suppose. What do you think? I know you don't know, but what do you think?
Right. I mean, yeah, just to hypothecate a bit about them, what could be reality is one option is that you see them pulled off in part or whole out of a city like Austin where they've, you know, done ground truth
Mhm.
and they've gotten to the finish line of, in other words, their issues have become less and less there, and the dimensional differences in, say, Austin versus Boston versus Chicago, they understand Austin.
Mhm.
Remember, what we want to say here, and it's important to say, is that FSD is a general driving system. It is not something where it must be trained specifically for behavior in Austin and therefore it doesn't function in Boston. That's not true.
Mhm.
But there are differences. And right now, Austin and the Bay Area, in San Francisco Bay Area, is used as a sort of a test ground,
Mhm.
right? So I expect that they could pull all or part of them from Austin, and then they may take a strategy that every city they go into, they start this way.
Mhm.
That's completely rational. In fact, if I was an engineering manager who was concerned about this, I would ask for that. That would be my plan. Um, it's also possible that they do sort of a partial, right? So they say, well, they've gotten rid of them, say in Austin and the Bay Area, and they go, well, Chicago. Remember, they're kind of pre-running these cities with these validation
Sure.
systems that we've talked about in previous podcasts, and those systems they're not mapping the city. That's not what's going on. They're just sort of running through the entire roadway segments to see how FSD performs. And they can't, they obviously they're collecting data, but they can't deal with every situation. Like coming across one intersection at one time a day is going to be very different. If configuration wise, it'd be the same, but in terms of number of pedestrians or cars or
Sure.
bicycles or whatever. But I think to answer your question more directly, I think the safety observers will probably continue for some period of time, and then all of a sudden we'll see them just disappear out of the system. I don't know what that all of a sudden is. It could be 2 months, it could be 3 months, it could be 5 months. I think it's somewhat immaterial, right? From a business model point of view, sure, they cost money, but it's immaterial when you get to scale. Um, and at this point, if you're looking at just from an engineering focus, they are incredibly valuable as a set of eyes that, you've got the cars are recording the data, but the cars don't have this kind of,
Right.
overarching AI that's observing the system itself
Sure. Sure.
and giving kind of quality feedback. And frankly, the customer's not there to do that. That's not the customer's job.
Mhm.
And often the customer can't push the information in a way that is receivable by the engineering organization.
Yeah. Yeah.
So,
I think we get it. Let me take a side trip here to subject number 2, very related. FSD 14, according to Elon, is 2 to 3 times better than a human driver. I don't think even the average bull got it last week, how important that was. There was a lot of back and forth. Cern Basher, Brian Wang, others were talking about, hey, wait, this is really big. It's really a big deal. I would think this is a game over statement. Elon says it'll take a few months to debug, fine. But then in saying that it's a 2 to 3 times safer than a human, this is an SEC type of statement. If he's wrong, if he doesn't have the data to back him up, the SEC would be all over that.
Yeah, yeah.
So I think he's got the data, and if he's got the data, it would seem to me that any regulator seeing the data, if it's that clear, would have to say, yeah, go for it. In fact, we may have to make this a requirement, not merely a license. We may need to require it on all vehicles if it's truly 2 to 3 times safer than a human. Anyway, what do you think's happening engineering wise? That's really where I want you to go with it.
Yeah.
Is what's happening engineering wise on FSD 14 and the integration with where we are with robotaxis, et cetera.
Sure. Well, I think there's two paths going on here. I think there's a maturation of the 13 series for robotaxi. So the customer vehicles today, I think the current version is 13.2.9, and that's about maybe the 6th to 8th release of 13 on hardware 4 vehicles. So I think what's going on here is that they've taken that model and before Robotaxi with so-called Project Rodeo, which was their employee test version of Robotaxi in Austin, and then now with Robotaxi operating in Austin and the Bay Area, they've taken that 13 and they fine-tuned the hell out of it. And so it's about 6 to 8 months ahead of the 13.2.9 release. And so, whatever it exhibits its behavior, it's way better. So I see a lot of people saying, oh, I don't see how Robotaxi XYZ can do this, can do that. I had an intervention yesterday. I'm like, well, you're using a version that doesn't even resemble that version, frankly. Okay. So now what they're doing is that they've got a parallel track, and the parallel track is version 14. So let's kind of peel this back. The difference between version 13 and 14 at the most principal level is that version 14 is a neural network model with about 10x the number of parameters. Now, without getting into the weeds on that, the best way of describing that is that it gives the decision tree, the framework of the neural net, more nuance and more decision points, if you will, to encode the driving function. So I like to think of a neural network as you pour data in, training data, and you build a function. And that function's outputs are accelerator, braking, and steering angle. Okay. And unlike a coded function where a programmer writes a bunch of code, it's this set of weights and biases known as the parameters of the network that take unseen data, new data, data that is presented from any particular robotaxi drive or any FSD drive in any city across the United States or now Australia or where, and outputs those values. So it's a driving function, right? Okay. So that function is got a set of weights and biases. Those numbers are meaningful. Not a single one isn't directly meaningful, and you cannot pull it out and say it did exactly this, but the box of them as a whole. Okay. So FSD on the ground today is the 13 model has a certain size to that model. We could characterize that any way we want. But what we would say, like we could say it's 2 billion parameters. I forget. I think I sort of had some sizing on it at one point. Version 14 is about 10x the number of parameters. So inherently, it has more decision points. The function's more rich or nuanced. And so now what does Tesla do? It's got the 13 version running on a parallel track. They're taking data sets and they're labeling those data for drive problems that they see in the field in the Bay Area and Austin, and they're feeding them through and they're fine tuning that model. Essentially, they're creating new versions of the build. And then when they think it's good enough, they put it into the field. They may put it into a non-customer based system first, and then they introduce it into Robotaxi. But all of the data that they use to train version 13 and all this new data that's training these Delta builds is being kept somewhere nicely in a box. Okay. And that data, possibly with a lot more, is being used to train this new model 14. So while there isn't a direct linear relationship between the size of the model and its so-called safety, there is a relationship between those two things. And the reason that they didn't build a 14 2 years ago or whatever is largely a function of compute, right? I mean, to build these models, to take the original data and run the multiple epochs required to create the model, not the fine tuning of a model, but actually starting with a shell of a model initialized to 0, if you will, and setting it with its values for some candidate build is a 2 to 3 months full on 24/7 process in the data center. Right. That data center is running flat out doing this. I mean, there's some checkpoints along the way and they're testing some things along the way, but frankly, it's running flat out to produce this model. So that's a parallel track. You know, they're taking a certain number of CPUs in Cortex and they're saying they're dedicated towards building this new model. They've got a certain set of CPUs there that are dedicated for testing, creating fine tunings on 13. So essentially, to answer your question, they've got two parallel tracks here. And I think what we'll see is 14 will be better because it's a bigger model and probably has been trained on more data. And it will then be rolled out onto Robotaxi and then hopefully soon thereafter to customer build. I also think that 14 has something kind of a little bit different, is that I think it's a superset release in that I think it can operate in both supervised and unsupervised mode.
Yeah.
And it's important to understand that they're not exactly the same thing, right? The idea that that someone can come in and create that intervention and that person needs to be watched in that they're supervising the thing. That's not directly part of the AI, but it's part of the overall framework, and it's probably being pushed through the context of it. All that is to say that the version that's in our cars today, 13.2 whatever 2.9, is the supervised version of FSD.
Right.
And the version in Robotaxi is effectively the unsupervised version because, for all intents and purposes, in fact, I think that version that's running there is already capable of being supervised and unsupervised, because in the Bay Area, it's operating in supervised mode because of the regulatory issue, right? So the difference is that in Austin, we have safety observers and they're sitting in the passenger seat. In the Bay Area, we have safety drivers and they're sitting in the driver's seat ready to intervene because Tesla's required to do so. If they weren't required to do so, Waymo was required to do exactly the same thing. So it's not like Tesla's being treated specially or poorly. It's just California's rules of engagement. So that said, you know, this is, I think, the version 13 that they're using is already kind of a modable system, meaning you can run it in supervised and unsupervised. I think 14 has got that as a conditional feature of it.
All right, let's take a hard right turn, or left turn, or I'm not sure which kind of turn, because actually we're talking.
I like all these driving puns.
Yeah, well, and besides that, this one is going an upward turn. I don't know what turn that is. So StarShip 10 was perfect. And Brian Wang last week has already told us what happened and what happens next. CERN Basher is going to explain over the weekend what it really means to the future of the United States and the world, which I think almost nobody, even the biggest bulls, understand. But I want to know, what about the engineering impressed you? What happened with the StarShip 10 that was like you're sitting there going, oh my gosh.
Yeah, well, part of me is just excited that it all came together and worked.
Right.
If you're an engineer, so now let's look at StarShip. It's really a bunch of subsystems. There's at the most obvious level, there's the booster and StarShip itself, but there's the launch tower and there's
Yeah.
comms and controls, and there's the people who focus on the Pez dispenser inside for there's a whole sub team for that. There's teams that work exclusively on maybe heat tiles and heat incursion kind of things. Then there's a whole team that works on the Raptor engines and getting them ready to go, and so all these teams have to come together as a whole to emit this project. And to me, it's like a much bigger project than something like FSD from that perspective, right? Because it's a multi-team, multi-discipline type of thing. So all these teams, before this happens, they're focused on their individual area. They are building up their, they've taken feedback from the previous launch, good, bad, etc., and they're applying that with Elon's guidance, and then they're also leaning in and testing new things. Like they talked a lot about, we pulled off a certain number of tiles to see, what that could do, and there's places where they might have tried different types of tiles and different types of adhesion of the tiles, and all sorts of interesting things like that. So they're constantly testing. So they've got this like feedback from before, plus a whole new set of things that they want to add. There's a balancing act there, right? Because you can't go full in. You got to cure the previous problems. You can't just version cure it. Version cure it is like, oh, I got a new version. I don't have to worry about the crap that I did before, because you have to, kind of bring it forward. At the same time, kind of not bring it forward, right? You're doing something sort of new. And you put all that together and you run that as a complete system. Now, in this case, it's a very exposed system with dramatic outcomes.
Yeah,
Right?
Yeah.
Dramatic outcomes. So it either succeeds brilliantly or fails brilliantly. And if you're looking from an engineering perspective, part of you is, I hope that team's got their S together, because you want the thing to succeed, right? Like, StarShip doesn't do well if Booster doesn't get it off the ground.
Right. Yes.
Right.
Yes.
So, like, if you focus an extreme amount of energy on StarShip, I don't know what version they may subversion that, StarShip 10, and then Booster doesn't get you there, doesn't get you to the point where you get separation, hot stage, then you're just waiting on the next the next thing, and you got to wait on this other team. So there's a lot of emotions that go through you, I think, as an engineer. Is that you work probably tirelessly, tediously to some point of, okay, then the day it occurs, you're feeling it's not good enough. There's no way you're feeling it's good enough. If you're worth anything as an engineer, you're thinking, this thing's not going to work.
What could I have done? What did I miss?
What could I have done better? And then, when it actually launches, that's the point where you just cross your fingers and hope, because, then you're done. I mean, I shouldn't say you're done. I mean, there's a lot of folks that are actively monitoring telemetry, but there's a lot on autopilot there.
Yeah.
So it's not like you can fix a tile, while it's up there in process. So, I mean, there's a lot of things going on that are both engineering discipline things, multi-team discipline things, and then there's just a lot of emotions, because, engineers are humans at the end of the day, and they have
contrary to many people's.
Yeah, I mean, there's a lot of, I think what's unique about some program like StarShip, and I think a lot of Elon's companies, is that the team has mission. And we shouldn't, we should never break from that idea. A team that has mission is a team that will succeed, or will have the best chance of succeeding. I see that all the time in Elon's companies. He's creating a mission. He's let's take the hill. Okay. And it's incredibly important. You got to have a mission objective that's tied to an overall mission. Like Starship, as I said, is so many moving parts that if you're working on just one little piece, you can kind of get absorbed in that piece. And as an engineer, you better get absorbed in that
Yeah,
piece.
yeah.
But there is a point where you have to come up for air and say, okay, what's the overall mission?
Mhm.
I'm on that mission. And you could say that the mission is to successfully do what they did, which is outstanding. But actually, part of it is to fail too, right? Because this is what we're doing in the case of we can't do it with FSD. We can't like just throw it out there and have people die. They do that through simulation. They do that
Yes,
through
yes.
through their own testing process. But in the case of Starship, all you can do is launch it. It's in the public eye. You can't do that in a lab. You can run a lot of simulation, but at some point you just gotta fire that rocket. And if you do fail, um, the idea is you fail fast and move quickly to the next iteration.
All right, on another complete hard turn here. You commented this morning. Elon mentioned Master Plan 2 will be completed in 2026.
Is that
Master
two or
Plan,
four? Oh, I'm sorry. Go
well,
ahead.
number 2 will be completed in 2026.
Yeah.
Master Plan 3, of course, we know is underway. That's the one we're working on mostly now. And he's getting ready to release Master Plan 4. And he says that the Master Plan 3, he says, was maybe too complex. A lot of people didn't really understand Master Plan 3, and that Master Plan 4 will be much simpler. Then you said, hey, send me your ideas and I'll write it up for you so that it's easy to understand.
Yeah.
I'm
Can
thinking
you imagine like I'm gonna make sense of
I
it?
know, I know, I know. So I was, so I realized that you were given some jazz there. So, but I've been saying for a week or for a month now, I suppose, that we should, well, actually, since I started reporting on Elon over 3 years ago, always listen to everything he says. And what he has said recently is he's thinking about a gigafactory for solar, and he has a plan for that, meaning the energy problem that we have right now as a country and the energy competition that we're in with China. Specifically regard to those two, he responded in a post, I have a plan for that.
Yes.
And if you
Yes.
take those two things together, in my head, what he's saying is, no, 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 I've got a plan. Probably has to do with solar power and batteries. He's also made several other additional comments this month with regard to the solar battery combination. I think the plan 4 is going to be heavily influenced by solar battery and his plan to make America the energy king of the planet. But I could be completely wrong. What do you think about Plan 4?
Well, I don't know what the energy plan is, but I definitely think it's in the plan. Um, no, I mean I think it's an incredibly important thing, and he's put on so much signal here. I mean, you're alluding to that, but I probably a good 15 posts over the last 2 months have given us some idea that he's thinking about energy. And why do we need energy? We need energy in this particular case, electrical energy. This is what we're really talking about to power the things that the AI revolution and to stay ahead or and I think that I don't know what the entire package, he's either I mean, I do think it's a solar battery play, but look, that's not my field. I think that, but I think he recognizes what's happening here. And what's happening here is that um, it's a very necessary ingredient for the competitive landscape of AI. Um, these we've learned through that incredibly awesome paper called The Bitter Lesson that today, at least for today, that the next best AI has a lot to do with the amount of compute, right? That you can compute your way to intelligence in some fashion of that word. And that compute is enormous, and he has spoke to that compute requirements on Colossus, which is a training center in Memphis, and he's talked about going from, I don't know, I'm just gonna kind of ballpark it, 100,000, 200,000, 300 to a million GPUs, and then ultimately to 50 million in a 5-year. I mean, so just think about that. That's insane, and I don't think he's being hyperbolic. I think he thinks that that's the need, and I'll tell you why in a second, or tell you why I think part of that is true. And then he's got to power that thing, and he's not going to get power from the grid at scale like that. And he's talked about bringing in his own power plant, which I think is in process.
Yep.
So I assume it's a natural gas fired power plant. I wouldn't know, but I'm guessing that's what's going to, sitting on the property, to augment and deliver the power required for Colossus 2. And if you look at China's leaning in really heavily now on solar, right? I mean, they're obviously, they burn coal with abandon, and they don't really care about the outcomes of that, and they don't, it's a different kind of thing. But they've also, they're not stupid. They're not just burning coal with abandon to the point where they'll run out of it. They're leaning in heavily on solar, and because of the nature of the beast, they're able to do that by making decisions at the top without all the public discourse and BS that goes on in our country. So I think Elon has recognized that, in the current administration, regretfully, that the energy policy is drill baby drill, which is fine. Like, go ahead and do that if you want. But at the same time, sort of lean in on the future of energy as well. And I don't think the administration is really doing that. And so I think Elon finds himself needing to tear off and come at it from a private perspective. I mean, if you want an analogy, you could look at, how are we going to get to Mars? Okay, Elon could spend all his cycles trying to cajole, prod, fund NASA to go somewhere, and you're still behind all the large contractors that move at their own pace because of how they get paid, or even create SpaceX. Right.
That's a pretty good analogy.
So on the energy front, you can sit there and maybe, frankly, say maybe this way, maybe Elon learned his lesson through his time at doing Doge, that while his process for doing it was different, while his outcomes were promising and good, they just weren't in his control. So I think the whole point about his energy policy is to bring it back under his control. And then I think the benefit to him is, he's like, well, then not only can I do it under my control, but I can, if I see an economically viable, awesome outcome to this, I can now, make Tesla 10x its size because of just energy alone. So there's all these multiplying effects, but I think we need energy, and he's recognized that, and he sees that our policy isn't aligned, and he's just going to go it on his own. I wanted to say why I think we need energy more than most people think. So what's happening in AI is that we're starting to see, as a society, we're starting to see this benefit to AI, and we're starting to see the marginal use cases tick up to complete, a complete kind of societal way of looking at, like AI will be everywhere, AI everywhere, right?
Right.
Which means that then we need to dial up inference to the next level, and that is, in traditional AI, we think of today, they're neural networks. It's an asymmetric kind of architecture. They're trained. We talked about that earlier in this podcast, about how much effort it takes to train a version 14, and then they're used. And the use of them, of course, is what we refer to as is inference, right? And that use is ticking up dramatically. And how xAI is approaching its future um, with its macro hard
Mhm.
initiative
Yes, yes.
is it saying we don't need things like applications. What we need to do is simulate. We just need, Elon has spoken to this. He's talked about this several times. It started to leak in something he called the bitstream. And what he spoke about is everything can be run through an AI in real time to get outcome. So that means that instead of having hard coded video games that are scenario based and this, that, and the other thing, and levels and all these things, we can generate video games in real time. It means that applications that we think today as binaries on our iPhones or MacBooks or PCs will blow up as well, and that they can just be simulated, if you will,
Yes.
through an AI. All of that means that the level of compute in the inference side is going to go up by a factor of 10, 100, 1,000,
Million.
10,000, a million. Yeah, this is going to happen. So we're going to find ourselves somewhere along the line desperately needing electric energy to I mean, it's not just battery, it's use of energy, because today most of the inference is done in the data center, right? It's not edge. We talked about this last time, that a lot of it is going to be moved to the edge, and a good example of that is embodied um, AIs like in, well, frankly, FSD
Right.
and
Right.
Optimus.
Right.
Those are edge-based inference.
Right.
Um, those inference cases are going to explode,
Yes.
but the data center ones are going to continue to explode. So all of the thinking time to do anything that's generative, app simulation, anything is going to require more and more compute. And we're really, I think, literally at the first or second inning in this baseball game.
Yeah, yeah, yeah. All right. So up till now, we haven't been talking about things that are complex at all. But I want to end. I want to end on the most complex, I think, subject of the day,
We'll see.
because it's so cutting edge that I think that the AI world has really only discovered it in the last month or so. And it's only been popularized in the last week or so. And maybe you may not have even heard about it, but maybe you have.
I'm starting to get scared here that I,
Yeah, yeah, yeah. So when we started in this AI revolution, we were talking about that the bits of information that we were gathering were words or even parts of words. The training was done on words or parts of words. And then that training moved to phrases or parts of phrases, so that our bit, the thing that we were encapsulating in turning into a, I forget the word already, into a, yeah, never mind.
like
In,
a, you're talking about like
token,
tokens.
into a token, yeah. So then we were taking phrases, and phrases could be a token, and we were opening up the window, if you will, to, instead of a page, we were talking about the entire Harry Potter series, according to one pundit the other day, being the size of the inference windows now. What is now being talked about is that words and phrases are not big enough to train on. We're running out of the data to train on words and phrases. Not only are we running out of enough data, but the training, the potential for even training on those is we're running out. And so what the systems now need is an environment to become tokenized, if you will. And I don't fully understand. I kind of get it. Okay. So we're going from a phrase to an environment, which is going to be the humanoids world. It's going to be the Tesla's car world. And the people that are talking about this, that I was listening to these various podcasts over the last few days, were talking about that basically self-driving cars like Tesla and the humanoids are the only place where we're going to be able to get this kind of data
Mhm.
that will be the next training set.
Mm-hmm.
All right. Now, all that to say, I've been sitting here thinking all along that Tesla was going to be, oh, so dependent upon Colossus. And all of a sudden, it may turn out that xAI is really dependent upon Cortex for the next phrase.
Yeah. So I admit fully that I'm not directly caught up on whatever this little trend is, and things move fast here. So,
Boy,
but let's step back a second and talk a little bit about what's happened here. When we started training these neural networks, we took language in written form and we converted it to tokens. And tokens are just representations. You can actually think of one token equals one word, but sometimes there's subwords, like, in a longer word like super intelligence, there might be like 3 tokens there or something, right? And it was a way of encoding language into a bunch of numbers, because after all, the AI is working on numbers. It's not working on the actual word. So what's really super interesting about these LLMs, these large language models, is that they completely are changed from the input to the output to just a bunch of tokens. The LLM doesn't know word at all.
Right.
There's a token translation on the way in, there's a token translation on the way out, and that just works. The inside, the interior is just numbers, and those numbers represent the words. So the reason that you did that, the reason computer scientists did that, is because they needed a way to, frankly, compress the input stream, down to something manageable. And so it's easier to train on an integer that represents a word than it is to look at the entire bytes of that word,
right.
And try to work it that way. And in a sense, it's more meaningful, right? Because you just have this one token that represents that thing. So now when you start thinking about where we need to go next, and we look at something like FSD's input is frames, video frames, and those are, in a sense, raw photon frames, if you will. And we talked about that previously, but to keep it simple, photons come in, that's a sort of an analog spectrum. It gets digitized down to these collectors, just like your camera does. And we were essentially counting the intensity of light through some filters. And then we take those and we put them together in some pixel dimension, a frame, a width and a height and certain resolution. And then we gather a bunch of those frames, because if you step them over time, it's video, right? It goes from still image to video. And then we package those together, and that's this set of frames is what's used to both train and run the inference of FSD. So if we start thinking about that, now we're looking at, so FSD as a neural network doesn't deal with words, doesn't deal with tokens in that sense. It deals with digital data, but that digital data is really camera frames, to keep it simple. There's some other stuff, but camera frames.
Mm-hmm.
And so it's all visual data. And the AI learns from that visual data to both perceive and plan its moves, to output its control values, accelerator, braking, steering. Okay. And it seems like magic. In some ways, I think it is. In some ways, I think it's just obvious, but both are probably true. Now let's go to something like Optimus, right? Optimus also is going to perceive the world in principally a visual way. May be able to touch and sense things from touch, and it's obviously going to understand audio or sound because it's going to use that. But it's a open-ended input stream, that doesn't end. In other words, its driving is really confined to roadways, and Optimus is not confined at all. It goes around the world like we do. So if you take something like Optimus, and you take something like these embodied AIs, Optimus, and our friend FSD, and you kind of total up the set of eyes that are out there, it starts to exceed the human number of perceptors, sensors by a long shot. And so what's happening here is that it's a sort of flywheel effect. There's more and more input data that's not in written form, right? And frankly, written form is just compression anyway, if you think about it. Like you and I have thoughts. If we can put our thoughts together in sentences and paragraphs, and we can write that article or write that book, and we can, in theory, educate somebody else. We have just compressed something. We've compressed all those thoughts, which are all sort of an input of stuff that started in the analog and ultimately ended up in the digital thing, which is the expression, which is words, right? We've literally compressed
Right.
knowledge into something. Now, it may have been a very lossy compression. We may have missed things. We
Yeah.
may not be explaining well, but it's still that.
Right.
It's still that.
Right.
But vision, okay, yes, it is another analog to digital conversion of data, but it's so much more, right? It's so open-ended. And what we're going to see is just this incredible explosion of input data, right? Incredible explosion of input data. And so maybe that's what this whole area is, but even if it's not, I'm close to it, I'm sure, because I think then we end up in a circumstance where we're saying, well, all the things we said about energy, compute, inference are, like the inference required on Optimus. No wonder why Elon's doing AI 6, because
Yeah. Yeah.
Optimus is going to be one of the biggest inference machines on the planet,
Yeah.
because it's not only going to have to perceive the world through vision and some other sensors, but it's also going to have to be a walking, talking CP3O to us, right? It has to deal with human language translated from the audio spectrum into words, and run through its own LM, call it Grok, whatever you want. And it's got to build up in a massive context window, because you're going to have an expectation that you could turn around and say to Grok, do you think that, or remember when we visited Randy's house? Does Randy have this book on his shelf, or can you tell me all the books on Randy's shelf? That type of thing, right?
Yeah. Yeah.
So, all of a sudden we have kind of a multimodal stream of information, principally vision, which is the heavy stuff, coupled with audio and some other sensor stuff, coming into this rather large environment that needs to run through an AI for proper outputs, whether that's responding to us or creating actions.
Yeah.
So
So part of the theory here, just because we're gonna have to wrap it up here in a couple of minutes, part of the theory here is, I think that we saw companies seeking data. All the major companies, all the leading folks were out trying to get data. They just paid the New York Times $60 million or something, for their raw verbal data. Other companies are out there buying and selling data right now. That's become a new commodity. What I'm thinking is, and one of the and what looks like maybe true, is that the data that Tesla has been gathering for all these years, and will be continuing to gather in even greater amounts as we get 1,000, 10,000, 100,000 Optimi out there, is going to be potentially worth trillions of dollars itself.
Yes, of course.
In order for these other companies that are not gathering that kind of data at all, can only get it really from YouTube videos or stuff, which are kind of not as good as the real world data that Tesla's getting. That this is a potentially an asset that Tesla has that is completely
Randy, you and I talked about this last time. If we have a robotaxi fleet that expands to millions and millions of cars in the United States. That means on a certain roadways in busy parts of a city, you're going to see a robotaxi every 2 minutes, every 1 minute. You're going to see them all over the place. Now take that input stream of 8 video cameras and aggregate it across the fleet. You have quite a bit of data. And you could use that data for driving the car, which it will do, obviously. But you could use that data for all sorts of other things. All sorts of other things. It would be able to tell us of any emerging problems in the city. It would tell us any graffiti that's been added in the last 5 minutes. It would catch somebody in the act. It would, so it's a perception of the environment that is outrageously real time, demonstrably real time, and overwhelming in terms of the scope. So without limiting the scope, you have a problem that is almost unbounded from a data input to compute kind of fabric. Hence why I would say to you that the demands for that will be, off the chart.
Off the chart. Yeah.
The potential to consume it and the demand of the consumption will be very, very high. And data centers and compute infrastructures and storage infrastructures will constantly be playing catch up, which is the world we live in terms of technology. We're always, trying to catch up, and the second we catch up, more stuff comes along, and so I think the outcome here is that we have a data rich environment. We have data that we are able to tap that is unseen today. And we as a society, from scientific, political, every potential area, have drawn conclusions on a scarcity of data, almost a statistically meaningless element, right? So we've said, oh, we're going to create policy based on this census. Can you imagine how poor the data is in the census, honestly?
Yeah.
And
We can go off on that for an hour.
yeah, and besides, the political realities of that,
Yeah.
if you just had a Tesla fleet in the form of robotaxi, not even the customer fleet, counting people, you've got almost a real-time census.
Almost, yeah.
You could see movement like you've never seen movement before of people, and not over some necessarily long-term trajectory, but almost like, just if you could just count, somebody's got maybe data on this and I don't know, but there may even be a company that does this, but you could just count everybody going in and out of airports, and if you just knew their final destinations, what would you know about, in general, the movement of people? And it's just sort of like, we know today that what our AIs do is they take in data and they use the past to predict the future.
Mhm.
Effectively, that's what LMs are doing. That's what full self-driving is doing in a way, right? Because it's saying, I've seen this condition before. It means stop.
Right.
Because if I don't stop, I get hit.
Yes.
So it predicts this future state.
Right.
And outside of what we've said before, black swan events, those things are very predictive, right? So it allows everyone in any realm of the societal kind of fabric to be able to use these kinds of inputs to get more meaningful, granular, and exposed, the more granular the data, the more predictive it is.
Sure.
Maybe it's a good place to stop before
I think that's a good place to stop. I think I got what I wanted out of this one for sure. That was, it was so much fun putting it together and so much fun to talk it over with you. And I'm not sure that there's a soul. I'm not sure that there's any. Let me know in the comments below if you've ever heard anybody talk about the potential capitalization of the data that Tesla is currently gathering. And it might be one of the biggest assets ever, and nobody's even talking about it. So with that, Thank you, as always, Phil Beisel, for coming on. You should follow him on X for sure, if you aren't already
please
doing
do.
it, because he's putting out a lot of commentary on X and, becoming kind of a regular for our Friday night or Saturday morning time. So thank you again, Phil, for being on board. And to
Thank you,
all of
Randy.
you out there, it's been great talking to you.